2020. And since then we had an amazing series of speakers presenting excellent examples of integrated building design from a number of architecture practices and environmental consultancies. So possibly some of you have already attended these events before. But if you missed any, or if you'd like to catch up, they're all available on YouTube. So you can go on YouTube, find the UCL IEDE account and find the full set of previous events. And now, again, thanks so much for joining us. And without further ado, while Rebbecca is trying to share the screen, I'll stop sharing. So I would like to introduce Rebbecca. Rebbecca Robinson is an architect and certified Passivhaus Designer at Architype Architects. Pioneers of passive house in the UK across all building sectors, where she has worked for 6 years. She studied at the Centre for Alternative Technology in Wales and has a background in sustainability. Her current work includes leading on the design and delivery of passive house schools and housing projects within the work of Architype. Notably, Rebbecca was the Passivhaus Designer for the Bicester Eco Business Centre, the first Passivhaus Plus non-domestic building in the UK. She is passionate about the social benefits of passive house and balancing the roles of project architect with the technical aspects of Passivhaus Designer on Architype's award-winning buildings. So yeah, we're honored to have you here with us, Rebbecca. So if that's fine with you, I'll invite the audience to put any questions they have in the Q&A or chat, and then we can take some questions at the end. Great, over to you.
Thank you, Anna.
Thank you.
Can you see my screen all right?
Yes, yeah, and it's I'm not sure if it's full screen, but it's almost full screen. I can see it fine.
Okay.
Thank you.
That's great. So yeah, thanks, Anna, and thanks for having me as part of this webinar series. As Anna said, I'm an architect and Passivhaus Designer at Architype. So Architype currently employs about 100 staff across our 3 offices in Hereford, London and Edinburgh, and we work on projects all over the UK. This is a picture of the Hereford office where I work, see the nicest setting. So we're a very people-centred practice and are 30% employee-owned company at the moment, with plans to become majority-owned within the next few years. So that means that we all have a part to play in the business, and have a say in how we want Architype to function, what kind of projects, priorities and division for the practice. So I'm going to talk about our approach to integrated design, or as we call it, design. Our holistic approach starts at the very beginning of a project and runs through to delivering the project on site, and extends beyond that into post-occupancy evaluation and monitoring, which is really the only way that we can learn from our previous projects and improve. So this has led to many successful buildings, both in terms of award-winning design and state-of-the-art low-energy Passivhaus and Passivhaus Plus buildings, which are responding to the current climate crisis we are all now facing. So about 90–95% of our current projects are Passivhaus, which is something that we've been advocating and learning from since our first Passivhaus project back in 2012. These buildings crucially perform as actually designed, with high levels of user comfort and still look and feel great. And we keep pushing the boundaries and taking on new challenges. So I think Architype is quite unusual in that we do all the Passivhaus calculations ourselves as architects. These aren't done by a separate engineering firm. So we have just under 30 qualified Passivhaus designers who are also architectural staff, such as myself. And as we work in these 2 roles at once, the Passivhaus principles are ingrained into how we design. So as this is our approach across all projects, not just one-offs, I'm going to talk more generally about how we design with an integrated approach, and giving examples from different projects throughout. So integrated design to us is about getting the basics right from day one, using environmental approach from the outset, and thinking about the services and structural strategies from this early stage as well. Keeping it simple. If it's not simple, it's hard to build and to build right. harder to maintain, more costly, both in terms of money and also embodied carbon. And working collaboratively from the early stages with a good and experienced design team and contractor team is also really important. We don't feel that buildings are about any one company or person's ego, the team effort. So just expanding on that comfort point slightly, as this is often something which is not necessarily always thought about, the comfort of occupants has a huge impact on how they experience a building. And as now people spend most of their time indoors, it can also have a huge impact on their health, which is why we think it's so important. So by comfort, we're meaning air quality, including CO2 levels, particularly important in learning environments, the air temperature swings, overheating, as well as acoustics, moisture and mold control. So I'm going to talk briefly about the evolution of our design process at Architype. I don't know if you've all heard of the performance gap. So according to CIBSE, on average, buildings use 5 times as much total energy in reality than when predicted at design stage. In fact, that's up to 24 times the amount for heating. And that difference is called the performance gap. So that's like buying a car that says it's going to do 60 miles per gallon and then it only does 12. So it's something that we think is not okay. So we seek to eliminate this gap in our buildings. We design buildings which don't use much energy, but all then also giving our clients buildings actually perform as we promised during design. So to do this, we need to integrate this approach from the outset and carry it all the way through. So that's where Passivhaus comes in for us. In the past, we lived in quite simple buildings. These tend to be uncomfortable and use a lot of energy to keep them warm. But there's a tendency now for buildings, especially those claiming to be very eco, to sometimes be over-designed with a lot of tech, lots of automated systems, so complicated that sometimes you almost need a degree just to operate the building. And if it's not operated as designed, because it's too complicated, that's one thing that contributes to the performance gap. And you can still sometimes end up with an uncomfortable building, which perhaps is overheating. So even we found through our work, even seemingly simple things like actuators, which automatically open windows, they can break. And when they do, it's quite expensive to replace them. And a simple window handle works pretty well. Everyone knows how to use it. It's easy and cheap to replace if it ever does break. So it's all about trying to make a building simple, easy to use, low energy, and comfortable. So an example on that, in our school classrooms, we always put CO2 monitors in there. So instead of linking these to a BMS system, an automated system, which then links to the actuators to automatically open the windows if the CO2 is high, we now just link the CO2 monitor to this very simple traffic light system. So if the green light comes on, the teacher and the children know that they should open a window in the classroom to purge the CO2. So we see Passivhaus as the best tool currently available to guarantee 75% approximately reduction in heating energy compared to standard practice. So hopefully you all know what Passivhaus is, but if not, it's a really rigorous energy standard with set energy and comfort criteria, which you have to meet to gain the certification. And this is all accredited through a third party, which means there's nowhere to hide in both the design and construction process. And this again contributes to reducing the performance gap. And crucially, we know that it works because we've monitored our buildings. So the drop in heating energy here that you see going from red to green is when we started doing Passivhaus. And this was our second generation of Passivhaus once we'd learned a lot of lessons from the first. So that was a 90% reduction on school baselines at the time. We also monitor indoor air quality. And monitoring CO2 levels is a good proxy of overall indoor air quality. I'll just quickly go through these graphs. This was the baseline case here showing CO2 in a quality in winter, which is when CO2 levels are at their worst because people aren't opening the windows. So baseline 1970s building here, you can see the CO2 is peaking very high at 5,000 parts per million. which is when your sort of cognitive abilities can start to be impaired. So not good for a classroom. The green line here is one of our pre-Passivhaus schools, so a slight improvement, but not getting down to where we want to be, which is about 1,000 parts per million, which our first generation Passivhaus school did achieve, and then second generation made an improvement on that. Mainly things like what I just talked about with the actuators, making it a lot more simple. Now, the big difference you see between the Passivhaus schools and pre-Passivhaus in terms of the air quality here is because of the use of the MVHR, the mechanical ventilation heat recovery system. So that's constantly supplying fresh air into the classrooms, not relying on the occupants opening windows and getting cold. So I'm just going to go through some considerations that we're taking into account when designing our low energy buildings. So this is about integrating environmental design from the start and Passivhaus. And some of these things sound quite simple, but are not always considered. So we look at the form of the building and often would calculate the form factor, which is the relationship between the external surface area of the building and internal floor area of initial design options, and compare these as a consideration. By having a simple form, you reduce the energy needed to heat the building in the first place, simply by there being less surface area for heat to escape through. And to highlight the impact of this, if you halve the external surface area of your building, you halve the insulation that you would need to achieve the same result. So I'm not saying we all need to just design boxes, but it's trying to avoid unnecessarily complex shapes, which are harder to make airtight, to build. But in this example here, just by taking some of those complex shapes out of the design, you instantly reduce the heating energy needed by 5%, save on area, making it cheaper and easier to build, and arguably creating a more elegant design. But sometimes simple forms can also be very beautiful. So this is the Imperial War Museum paper store, one of our projects, which is literally just a box, but design quality is added through the facade detailing and use of materials. This building has one of the lowest air tightness in the world at 0.03. Interesting fact here, there's actually no insulation in the slab of this building, which is unusual for Passivhaus. Because it's an archive building, lower internal temperatures were required. And so we had no insulation in the slab to make use of the cool temperatures of the earth to keep the indoor temperature down. So secondly, at early stage, we look at the orientation of a building, which is really important when trying to reduce energy use and controlling the indoor comfort. So one of our rules of thumb for early stage design is that a building's main glazed facade should ideally face south or within 15 degrees of that. So that dramatically helps to reduce the energy use by capturing solar gains from the sun in the winter. But it also makes it a lot easier to control those solar gains in summer to avoid overheating, as you can very effectively shade south-facing glazing with overhangs, which is much harder to do on the east and west, where the sun is much lower. So of course, this isn't always possible. That's an ideal situation, and other design factors may be more important, such as the relation to the street, the public realm, or you may be in a very constrained site. But the important thing is that this is something that we consider, and we know the implications of that, and then can mitigate any effects. So in a project example here from stage 2. So that's early stage design. Our designs don't start with an abstract concept sketch, but by thinking about the form and orientation, as I just said, ventilation, daylighting, the site constraints, the internal accommodation, the relationship with the outdoors, and having lots of consultations with the stakeholders. This is a primary school project, so we looked at 5 massing options on the site. Option 4 was taken forwards. And even though we had some reservations about the deepness of the plan, this design was favoured by us and the client as it has the best form and orientation, and for maximising the green space on the rest of the site. We then designed a public plaza to the north of the site to engage the building with the local community, create a sense of civic presence. The daylighting issue from the deep plan was remedied by introducing clear story windows, like in this sketch, which bring the light down into the middle of the plan, so yeah, reducing the need for artificial lighting. So this is an example of a very similar section on a different school that we completed in 2014. It's Wilkinson Primary School, one of our first passive houses. This is the south-facing orientation. This is the west-facing orientation. You can see the windows are much smaller and narrower. The orientation ties into facade design. This is a study that we did on window design. It's a delicate balance between daylighting, overheating, and views out and aesthetics. So these two facades here have the same amount of glazing in terms of area, but they're arranged differently. So glazing on the top sketch there, it's vertical glazing going down to floor level. So low level glazing isn't contributing anything to daylighting because you want the daylight at desk level, not floor level, but it is adding to overheating. It's harder to shade. The lower option, we've added shading if that was a south-facing elevation, and secure louvers for nighttime purge ventilation. And crucially, these need to be secure louvers so the occupant feel comfortable leaving them open at night. So it's all about having glass where you need it. So when you look at buildings elevations, I think you should be able to tell if that's a north, south, east, west elevation without labels. Each facade should be designed for its orientation as well as responding to the other context. So you can see that in action here. This is Hackbridge Primary School, which is one of our projects, the first Passivhaus Plus school in the UK, completed 2020. And this building actually generates more energy than it uses. This is an L-shaped building. So by looking at this, can you tell which of the wings here face which direction? The wing on the right, you can see that it has quite similar horizontal window arrangement to what we're just looking at in that sketch. And the horizontal overhangs show us that that's a south-facing elevation. And the wing on the left is for east-facing. The windows are generally much narrower with deeper reveals and vertical shading bars, which help shade the windows from easterly sun, which comes in more of an angle. There's also a beautiful example of a building integrating between architectural design and landscape design. This is Harris Academy Sutton, the UK's first Passivhaus secondary school, which interestingly has won both architectural and building services awards. You can see in the main part of the image there, that's the west-facing elevation, has very deep fins on the window to again provide that vertical shading. Whereas on the other side, we've got horizontal shading there. So moving towards the detailed design stages, as ever, delves in the detail, and we try to make our details simple with continuous high levels of insulation and thermal bridge free. So achieve this, we need to work in close collaboration with the structural engineers, in this case here, to design this really simple flat slab, so there's no pads or foundations below the main slab, with a timber Larsen truss system for the walls. So that's a load-bearing stud sits on the edge of the slab with the Larsen truss zone, which is the insulation zone, cantilevering off that. So that means that all of that structure can be fully wrapped in insulation continuously. So this limits heat loss and also thermal bridging, so you don't get cold patches, which have caused condensation and mold growth, which again is bad for occupant health. And again, with our detailing, we think about how this is actually going to be installed on site. So one actually has to physically build from our details. And if they can't build it, then it's not going to happen as we want. And the building may end up underperforming. So as an example here, this is a plan detail of the MVHR ducts coming in to terminate in what is basically an insulated window panel in the wall. The ducts need to be insulated for Passivhaus and then taped for airtightness and vapor control. The size of the ducts is coordinated with the mechanical engineer, and then we make sure that we allow enough room down the side of the duct so someone can get their hand in there to do that taping work. And all this goes into the developing all of our details. Hopefully it's a slightly dodgy site photo. Hopefully that shows what I mean there. That's, you can see that gap down the side of the duct and a ladder in the foreground. So as I said, we work closely with services and structural engineers for our projects, right from the early design stages. This example is for a client who wanted a repeatable workspace building with high levels of user comfort and to meet Passivhaus energy standards. So the starting point from the client was this like donut shaped building with our habitable spaces, office spaces around the outside of that. You can see here in green, and the circulation was around the inside of the courtyard. So our first move was to actually push that circulation space internally and bring the habitable rooms into the courtyard. So then they can be naturally lit rather than relying on artificial lighting so much. This also reduced the amount of circulation area. We then pushed in the centre to create these 4 wings, which created shading for the highly glazed area around the entrance and further reduced the circulation area again. The client here placed a strong emphasis on integration and repeatability. So what these wings gave us was 4 identical T shapes, which make up the building, each with a stair and service core at the centre, which you can see illustrated on those 2 bottom sketches. The orange boxes on the sketch on the right indicate the 4 MVHR units and mechanical ventilation system, which each serve one of those 2 sections running vertically through the building. So doing it this way, rather than having, say, 1 unit per floor, instead of split into 4 vertical, this allowed short distribution runs. So smaller ducts branching out from each of those zones. So that meant, in turn, smaller service voids, and so then we could bring the floor-to-floor construction height down. The floor construction is also designed so as not to have any downstand beams, to be one continuous element. So again, to keep the surfaces simple, they can just run straight through without having to have ducts crossing over each other, which again adds height to the service voids. So both these meant that we could reduce the floor-to-floor height, saving costs, and also then having the knock-on effect of bringing the building down low enough so not to require additional firefighting shafts. The WCs and showers are also stacked and located in those cores to minimise the pipe runs between sinks and showers, which bring unwanted summer heat gains and uses much less energy to keep that compact rather than having to get hot water to travel long distances throughout the building. So working with a structural engineer, this sort of grid system or tartan structural bay was proposed. By having this really rational grid system, the efficiency of the structure was much improved. So by not having sort of a completely bespoke system, complex junctions such as cantilevers, or additional structure having to pick up edges of voids and junctions like that. This rationalization reduces the amount of material needed in turn, which then brings down the embodied energy of the building, something that we're also very concerned about. It's also designed in an early stage to be construction agnostic, which means that it could work with different structural options at detailed design stage, like timber or concrete. So yeah, those are both examples of how we work with both the mechanical and structural engineers right from kind of early concept stages. And because of the high internal heat gains of this particular typology, some active cooling will be required in the building. So we're looking at using an activated concrete slab core as the lowest option of active cooling. So this involves piping cool water through the slab to take the heat out, which is gathered in the thermal mass of that concrete slab. So interestingly, this is cool water, not chilled water. It's about 18 degrees, so it doesn't we're not using more energy to cool the water down, and it could potentially just come straight from the mains. And using chilled water could actually create more condensation risk. And this piped water system could also be used as heating during the winter months. And along with that, we're also looking at not fully insulating the ground floor slab, like we did with the paper store. So using the mass of the ground to cool and stabilize the internal temperatures. So both these are, well, that's a passive example, passive design. So on some of our projects, our clients are now asking us to look at integrating climate resilience into our designs. So for this, the Passivhaus supported living apartment block for Exeter Council, the building was modelled using 2050 and 2080 climate data by the services engineers on the project. It was taking the 50th percentile of future climate options. So that's a prediction of what will happen sort of halfway between doing nothing at all to prevent climate change and achieving the best case 1.5 degree scenario. So we knew that the building would overheat in 2050 and beyond. So we used the test data to test various interventions that would help reduce the overheating in the future. And then we allowed for these interventions to be added into our current design now. So hooks were installed in the window reveals so that external shutters could be added in the future. So they're not there now, but the provision for them is. So those shutters would block out the solar gain during peak summer. So you can see from this graph that that's not enough in 2020. So shutters are the second line down in blue. So it also allowed for concrete pads on the roof at this stage, so that a cooling unit could be added to the ventilation system in the future once it was required. And that again brought down the overheating significantly. But what made a really big difference was sealing the building. So that would involve educating the occupants to not open the windows during the daytime to let the hot air in the first place. So when all these strategies are combined, you can see those bottom two lines there, that the building stays at a comfortable 19 to 20 degrees. That's in 2080. So yeah, we all know the effects of climate change are coming and begin to be here now, and this will impact the buildings that we're designing at this time. So we don't know exactly what will happen by any means. If we looked at some of the worst case scenarios in the modelling, then the building actually ended up being underwater. So, but we can make some predictions, and it's best to think ahead and do what we can now by integrating potential future interventions now. The building will still be usable in the future. So as well as working collaboratively with the design team throughout, we try to foster the same ethos with the contractor team. We've designed the building, but the people on site don't necessarily know what the overall project goals are, Passivhaus, for instance. So when doing Passivhaus projects, when a very high site quality is required and a very stringent air tightness result of 0.6 air changes, it's not just the site manager on site who needs to understand this, but all of the subcontractors. And education is really important for getting this understanding and making people engage with the scheme more. So it takes a little bit of a different way of working. The sort of services team can't come in and punch holes in the building without considering the air tightness, for example. So it's a much more sort of joined up approach between the different subcontractors on site than you might normally have. So we run toolbox talks like shown in this picture with the different site teams and give examples of good and bad installation and services, and sharing lessons that we've learned on previous Passivhaus projects. On a project recently, every penetration that went through the building was labelled with either QR code or a number, so then the air tightness ceiling of that could then be kept track of on site and evidence to the Passivhaus certifier. So the process doesn't stop once the building is completed and occupied. We monitor many of our buildings post-occupation for energy use, temperature, CO2, and go in and talk to the occupants. We also like to keep an eye on the decks, the display energy certificates, which show the actual energy that's been used, as well as carbon from the previous year. So this picture here is the Enterprise Centre at UEA, which has received a DEC A rating for the 7th year in a row, which we're very pleased about. And the other image on screen shows the kind of live data that we have for one of our primary schools when we're doing a series of monitoring there. So I'll end with a photo of the Bicester Eco Business Centre, which is the first non-domestic Passivhaus Plus building in the UK and is zero carbon in use. And this provides a mix of co-working and serviced office spaces. And also by saying that, just to end on, that there are a lot of challenges in the industry at the moment and in the world, but encouragingly, the momentum for change just seem to be building at the moment, and that's seen in the construction industry shifting towards more low energy buildings which address the current climate crisis. So I'd say it is a really exciting time for students to be moving into the industry, and many councils and organisations recently declared climate emergencies and are coming to us looking for passive house and zero carbon buildings. Hopefully you all saw in the recent news that the Scottish Government is planning on bringing in legislation in 2 years' time that all new build housing will need to be passive house standard or Scottish equivalent. So that's really exciting, and hopefully the rest of the UK will follow, and this will extend into all new buildings. Great, so thank you very much for listening. I think we'll open up to questions now.
Excellent. Thank you so much, Rebbecca. Yeah, unfortunately, I can't switch my video on, but we have one question in the chat. So I'd like to invite our audience to add any more questions they'd like in the Q&A. So Dominic is asking, how do you integrate research in practice? Is this something you budget time for on each project, or a full-time, part-time role across the company?
So good question. Yes, we do integrate some research. At the moment, just a little bit of both. So at the moment we have links with people in industry, or some people doing PhDs purely looking at monitoring a building, for example. She works with us monitoring a number of our finished buildings. And that's presented back to us, and how then we can integrate that into our future designs. But then, yeah, we also have people on project teams, yeah, looking at our current modelling, yeah, and passing on lessons learned from previous projects is kind of built into the project time. So that process we would go through at the beginning of any new project, and at the end of a project, that would all be fed back.
Yeah, and I have to say, Architype are an exceptional practice. So I have to mention I co-supervise a PhD student sponsored by Architype in indoor quality in schools. So yeah, I think yeah, you're doing a great job in terms of integrating research into your design practice. So yeah, again, thanks for the excellent presentation. I probably have a lot of questions myself, but I can see the questions they keep coming. So one more question from our audience. What would you do to old houses or heritage if they want to take a passive house approach to reduce energy use?
Yeah, great question. Something that I didn't touch on in the presentation. So we actually do have quite a lot of work retrofitting existing buildings, which sometimes include listed buildings, and to passive house levels. So there's a passive house standard of retrofit called Enefit. So yeah, it's all looking at the same principles, but trying to be a lot more sensitive, and obviously it's a bit harder to work with an existing building, so the Passivhaus criteria is relaxed for NFIT. But yes, we look to insulate walls and always use breathable construction, which is less likely to have a problem with existing buildings. Yeah, we've got a number of approaches to keeping kind of retained and listed elements, such as like cornicing or dado rails or timber paneling often end up being listed elements. So it depends very much on the local conservation officer and their approach. But sometimes they're happy to keep that and cover it up with insulation, but sometimes we would try to carefully strip that off, insulate and then reinstate or replace. Yes, could talk about retrofit for a long time, but that is something that, yeah, that we are doing a lot of and putting a lot of research into. And
amazing, thanks. A question from Neil. What's Passivhaus Plus? So you.
Sorry, I should explain that. So Passivhaus Plus. So Passivhaus Basic has criteria for heating energy and overall primary energy, so that's all of the energy in the building, taking into account the primary energy sources, how it got to the building, but doesn't take into account any energy generation. So Passivhaus Plus, and there's another one, Passivhaus Premium, which is above that, does take into account energy generation as well, and sets slightly harder goals for the primary energy.
And a question from Neil. Do you use SketchUp to PHVP in early stage design?
Yes, that is something that we use. Yeah, the Design PH SketchUp plugin in early stage design. And we've also started using it in later stage design. When you've got very large, complex buildings, we sometimes use it to calculate the shading factors on all the windows, for example, because that'd be quite hard to do manually when you've got hundreds of windows in a building. Yeah, it's a really useful piece of software.
Eleonora is asking, do you have any external people advising you specifically on how to design the schools? Presumably educational experts. Or...
Not that I know of, no. We have sort of quite extensive experience ourselves in-house of designing schools. But if we had a particularly specialist school, we would perhaps seek some consultation from outside, like ASN schools, or any schools with particular specialism is maybe when we look to seek outside assistance.
Quite a few more questions coming. How challenging was it getting the desired U values for the building fabric and also getting right on the PHPP? What for sort of kind of new build projects, I guess, or any project? I don't know if you would like to clarify. Yeah. To be honest, it's not that, we don't find it that much of a challenge. I think, I mean, personally, I haven't worked on a non-Passivhaus building for so long now. That is just your normal. It's normal. Yeah, it's quite easy. So that example I gave where we showed the detail Larsen Truss timber construction to that flat slab, we normally would have, say, 140 structural zone and maybe 200, 250 insulation zone. So that makes up sort of 400 mil thick walls. So they are thick, but particularly on projects like schools, we aren't that constrained on site area to be limited by how thick the wall can be. And if we're at that stage, we already would have buy-in from the client and the contractor, and they know what's coming. They know more insulation is needed. It can be a little bit more of a challenge on housing, say, where the site constraints are a lot smaller, or contractors want to use a particular process. So going back to NRFIT, Laura is asking whether you undertake projects that focus on NRFIT, retrofit. I guess retrofit comes with the, many different challenges compared to new build.
Yes, so yeah, as I said before, yeah, we're working on a number of MFIT projects at the moment. Yeah, across, well, mostly schools, I think, and also public buildings. Yeah, and sometimes those buildings are also listed. Yeah, because retrofit is very important. There's a lot of existing building stock that needs to be tackled, and like the lowest carbon option is to use the building that you already have.
Yes, yeah.
But make that more more usable in terms of energy and occupant comfort.
Absolutely. So the next questions are about monitoring and measuring performance. So Bernard is asking, how do you locate, measure and quantify air leaks during the execution of the build program and before the door fan blower test or pulse test? Okay,
before the blower door test?
Yeah, I think so.
Yeah. So this would be done by, I guess, regular site visits. So when we do site visits, we're doing that in an architectural and Passivhaus Designer capacity. So it's just going around spotting any areas that we think could be potential leaks, whether that's like mistakes in taping or anything, and building leaks like that. So visual inspection up until the blower door test. Which would give us a preliminary result. Ideally, you want to do that before you start putting linings in the building, so the air tightness line is still exposed, so then you can make any remedies if you need to. And during that, we would go in with a smoke wand, so you can sort of go around and you can see where any leaks are by that smoke being sucked into places.
Yeah. So the next question, I guess I can answer this about our jointly supervised PhD that indeed other pollutants were also measured, but in other projects, when you monitor air quality, Saya is asking, do you just monitor CO2 or have you also considered monitoring other gases pollutants, especially within Passivhaus archive storage facility?
Yeah, we mostly, so as standard, we would do CO2, internal temperature, and energy in a number of different spaces around the building. Like in a school at the moment, we do, I think, 4 classrooms, 2 on the north, 2 on the south side, because they behave slightly differently, and on first and ground floor. Because CO2 levels are a really good indication of general indoor air quality, including build-up of VOCs. Yeah, and as Anna said, we have specialist projects with the PhD student where she's specifically looking at VOCs, so volatile organic compounds in buildings, and comparing this with Passivhaus and non-Passivhaus projects.
So we have 9 more minutes and 9 more questions. I'm afraid that we might not be able to answer all of them. If that's okay with you, I'll go through the first few. Oleta is asking, how have you been managing your works in terms of cost and relevant codes? So presumably building regulations compliance.
Yes, so building regulations compliant, obviously everything needs to be building regs compliant. We don't usually find that many conflicts between Passivhaus and building regulations. Obviously part L is we are way exceeding with Passivhaus. Sometimes there's little things like with part M needing a level threshold into buildings. Quite hard to find a Passivhaus suitable door that has a really thin small threshold. So we just have to work that into our details and make sure that we design so that threshold can be dropped down slightly in order to achieve the part M requirement. Passivhaus door, for instance. What was the other question? Costs.
Cost, yeah.
That's a big one. Generally, non-domestic buildings can be only slightly more expensive, like a couple of percent, or even similar costs to a non-Passivhaus project, especially when the key thing I think is if you can build up a really good relationship with a good contractor and design team, for example, that kind of repeating the process. So we've often done that where we've worked with a consistent team, and by the second, third time they've done it, it's not risky, it's not scary for the contractor anymore. They're not pricing.
You know what to expect.
Yeah, and the cost comes down to comparative levels. So we've done schools with comparative cost of sort of baseline. Welsh levels that are in Wales. Domestic tends to be a little bit more of an uplift, depending on where you are, but I think that's the same, and people make those design decisions. You know, if you want to go for really high spec finishes, that's going to have a cost uplift, as well as this. And the more common this becomes in terms of the technology, the cheaper the cost differences will be.
Makes sense. One more question about prefabrication. So do you tend to prioritize prefabrication where possible in your designs, and does it add to the delivery of a successful project, or not necessarily?
Not necessarily. I think we've done it both ways. Quite a common form of construction on some of the projects I've personally worked on is that there would be a timber frame project, timber frame construction, and that would come prefabricated in panels to site. So it does go up very quickly, which is good. And I guess the prefabrication allows a certain initial level of sort of quality assurance. On the other hand, we've worked on some projects using a steel frame system, which is less ideal, but more accessible and cost effective for some contractors. And having prefab panels can lead to damage in how they're installed on site, getting to site, being installed, especially if the airtight layer is already on there. That can lead to some problems because you have to go back and repair it. Yes, I think it's just about like quality control throughout, no matter what approach you take. But either is suitable.
So Ewan is asking, are Architype looking into the whole life carbon of your passive house projects? And I think this is something that comes up again and again when we talk about low carbon design, low operational carbon design. How are you keeping track of the embodied carbon in your projects? And what tools and rules have you developed to make sure embodied carbon is kept in check on passive house projects, which can be quite carbon intensive in their construction? Interestingly enough, I was in a webinar yesterday and the same issue of embodied carbon came up. And I don't know what your thoughts are on this and what you do within Architype.
It's definitely a key issue and something that becomes more and more important as we are driving down the operational carbon of the building. The embodied becomes a lot more important. So we do run whole life cycle carbon calculations on a number of our projects. Often these are done both at early stage. So in our even like stage 2 reports, we would run an initial calculation looking at say 4 different construction options and the embodied carbon of each of those, and to present that to the client, trying to get buy-in that way. So we actually have our own tool for embodied carbon called Eco Lab, which is developed with some industry partners.
So is that like an in-house tool?
No, it's a commercially available tool, developed between us and some of the partners. So it goes into a lot of detail. So we would tend to do that. Obviously, having gone through that process a few times, we can then use rules of thumb to apply to different projects. And I mean, we all know that going for a timber approach over steel or concrete is going to be better from an embodied carbon perspective. So that's something that we're really pushing. That is our priority, to push the timber construction. Often can get up against challenges with that in terms of fire. We're sort of involved in a few review panels and things in the background, trying to push timber use and fire regulations where appropriate, make that safe, of course.
Yeah. So I think we have time for one more quick question. So Anna Maria is asking, have you applied BIPV to any of your projects? Presumably that's building integrated photovoltaics.
Oh, sorry, could you repeat the
yeah, have you applied BIPV to any of your projects? I think it's building integrated photovoltaics.
Oh, right.
I think.
Possibly. I can't think of any projects off the top of my head. Oh, actually, I think we have some housing projects. If I've understood correctly, this is the panels which are you use as a roof finish as well. So we're not putting the panels on top of a roof finish. Is that correct? Yeah, so we find they are good because it makes the whole thing more cost effective because you're not doubling up on roof finishes. Yeah, but I think pretty much all of our projects do have PV panels of one type or another on at the moment.
Great, so I'm afraid we'll have to end quite soon, and apologies to all of the audience members whose questions we didn't manage to answer. I don't know if that's okay with you, Rebecca, if people whose answers we haven't replied, or people who'd like to find out more, if it's okay for them to contact you.
Yes, of course, yes. Yeah, I think you have my email address, so yeah,
yes,
feel free to pass on any questions.
Thank you. Thank you. And again, apologies for the delay in starting, but thank you all so much for joining. I have to say we have been running those webinar series for quite a while now, and it's the largest number of questions we've ever had, so which clearly shows that there's a lot of interest in passive house design across the industry and among our students and colleagues. So thank you so much again, Rebecca. I would like to invite a virtual round of applause. Thank you so much for giving out your time to give that presentation today. It was extremely interesting, and I had a lot of questions myself as well. Hopefully we can catch up at some other point. But thank you again so much. And yeah, we will soon announce the series of upcoming webinars, so please watch this space. And as I said, our webinars are uploaded on our YouTube channel, so please follow us on LinkedIn or Twitter for updates, and also you can subscribe on our YouTube channel. So I'll try to finish at 2 o'clock because I know people have to go to meetings, etc. But yeah, thank you again so much, Rebecca, and to everyone for attending today.
Great, thank you very much.
Thank you.
Yeah, thanks to everyone.
Bye.
Bye.
Bye.